All right, so just going to breeze through these real quick and point out a few things that might be helpful for just reminder notes for your drawing package. These prints that we're going to look at have got some issues. They're not exactly perfect examples. For example, this 3-inch dimension, there should be a gap right here on this leader line. The leader line, of course, is the line that the dimension is drawn to, the detail line. So it's worth noting when you click on something to dimension it, here I probably clicked on this point. Well, make sure you click the furthest point out. Otherwise, you're not going to get the gap that you see here. So anyway, keep in mind your gaps. If you notice things in these drawings, that's good. That means you're learning. This one, if you're using structural shape, it's probably a good idea, or at least helpful, to you and the person making it to just call out what that structural section is. If it's 4x4 square tubing, call it out that way. If it's 3x3 or 3x1/2 flat bar or something, call it out as a stock, dimension. Even though I set it here, it's 4x4/3/8. It's just a nice kind of extra thing to do. That being said, I would never think that this note could take the place of these dimensions. So keep that in mind. A lot of times too, you'll see a note next to a dimension like this, 4-inch stock, and you'll write out stock next to it. So that's something else you can do. And then you can completely ignore doing this note, but they're both ways of doing the same thing. Remember, through holes should be labeled as so. If you're going to say typical, that's great. Or you could say, 2 places, or you could say both, typical, 2 places. Different ways of saying the same thing. Obviously, the tolerance on these are kind of silly. This was sort of a project that was the drawing package that was done after the product was built. So ignore those tolerances. Don't forget your finish requirements if it needs to be finished in any way. If not, say self-colored, but don't leave that up for, question. Don't make the person wonder. Let's see, let's move on. Again, we've got the angle here. It's a good idea to pull out actual cross-sectional libraries instead of just drawing your own angles, because like you've got these radii that are going to be on these. If you're using CAD software and those things are already in it, great. If not, if you manually drew that angle, you should probably just go online and pull up a DXF of that structural library. There are plenty of free ones available, and then you can at least get this 2D shape and then extrude it out or something like that. But if you don't show radii on your drawing that are actually going to be on the product because it's a structural shape that's produced that way, it may lead to some confusion. Keep in mind your views. This is a good example where only 2 of the many view options that are available, only 2 were used. You've got a front view and a right view. Just use what makes sense. This was kind of a crazy looking part, but as complicated as it looks, it's really just a piece of channel with one cut made on this side and some cuts on this side. So it could easily be shown really most of the data is given in this one view because it was really all 2-dimensional work that was done to the part. So you don't need to overcomplicate it with a lot of views sometimes, especially starting with a structural shape. So, take advantage of that. You can have clean looking prints if you just use views that make sense. So you get to pick what the front view is. It doesn't have to be oriented by where the operator, where the user is going to stand on the end product or something like that. If you're doing a drawing of a car, front, doesn't have to be, or a car part, like maybe a door for a car. The front doesn't have to be the front of the car. It can be whatever view makes most sense for laying it out on your drawing. I know that probably doesn't follow with like aerospace drawings. A lot of times things are drawn with reference to the, front of the aircraft or something, but there's no rules that I know of like that for manufacturing drawings for structural things like this. So, yeah, I can't think of anything else here. This is a good example of a typical, right? Because this is 2.28 is also 2.28 up here. No need to dimension in both places. It's kind of like if it looks the same and you say typical, then it is the same. Could have said 2 places, would have been just as good, but typical is also okay. These are all stock dimensions. They should probably say so. Um, 0.24 stock, 10-inch stock. That way everybody knows that I don't have to go and machine that down to 10 inches because it already comes that way. Another good example of, just using 2 views. And really this view, all it does is highlight stock dimensions. So those should all say stock, and then you're done. This might be a little bit of redundancy here, labeling the length of this and the length of this, and then also the angle. But for manufacturing's sake, it's nice. If you do over constrain a drawing by putting all those things on there, I think, for example, one of these, top or bottom, should probably say reference, because I think by the time you've dimensioned out the top and that angle and this height and this angle, you've probably already kind of, this should come out in the geometry, if that makes sense. So this may actually be over constrained. Be careful with that. If you do so, then, and you really want to have it on there because you think it's something that's going to be useful to measure, then just put that as a reference dimension. Or just don't put it on there at all. I prefer to have it on there, especially, when I know that this is going to be a little harder to measure maybe, and you start thinking about how tolerances stack up. That could become a little tricky. But also worth noting here, notice how this angle is not dimensioned. As a general rule of thumb, anything that looks like 90 degrees is 90 degrees unless it's dimensioned otherwise. So this looks like a 90 degree. That's why there's no angle on it. So if this is 39 and this is 90, then this one is already kind of decided, right? So if I would have dimensioned that angle there, it would have over constrained it. So, just keep that in mind. Don't dimension too many things on the same area, because then you end up, having, it really ends up being a tolerance issue, because then the manufacturer has to decide which one you care about more. Simple part here. Nothing really to talk about, I don't think. Again, these should say stock. Okay, so this is a good example of an assembly drawing. What we've seen so far, in fact, we kind of skipped this piece here, but we saw piece 1 and piece 2 and piece 3 and piece 4, and now we're bringing them all together into a assembly. And so these 01, 02, 03s match the part numbers. This is 07. 07 is a sub-assembly. So 07 is made up of 01 through 06. And so that's not the way you have to do it, but it's the way we do it at Tandem Lock, and it makes sense, and it usually works pretty well. Sometimes you might have your sub-assemblies digits will be maybe in this neighborhood, and their children parts will be in this area of digits. But it doesn't really matter as long as what you have is consistent and it's easy to follow. But your assembly drawing will show all the pieces coming together. It'll have weld, in this case, weld specifications on it, and it'll have some overall dimensions, and it may even have some dimensions for locating those parts. If those parts fit into holes, like they're bolted together, it's really not necessary, probably, unless you really care about the play in those bolts, probably not necessary to show location dimensions, because the bolt holes are going to already establish that. Now, if your bolt holes have a lot of slop and you think you need to put it in there, then, that's fine. In this case, it was all welded, so it had to show where all those parts were located. This is a good example of, staging these dimensions. Obviously, you would not want the 6-inch all the way out here. You want the smaller dimensions inside of the larger dimensions, so it looks nice and clean. It's good to bring them all from one point. That way, everything is established off of, in this case, the ground. Make sure that every piece is dimensioned in X, Y, and Z. If it's up against a part, well, then, that's as close as it can get to that part. Then you don't necessarily need to say that it's touching or anything like that. But, you need to look when you're done and say, did I show them where to put each one of these parts in 3 space, in X, Y, and Z? Uh, weld symbols can get a lot more complicated than what I show here. This is simply, this little circle means all around. That means anywhere around that part that there's a weld seam, I want you to weld it. It's a really quick and easy way of saying something. And when you can do that, if your weld's not going to get in the way, just do that. Welding all around is stronger and it looks cleaner and you don't leave gaps and cracks. Maybe you only needed to weld two sides of that plate because that's all the strength that was required. But unless there's some kind of maybe cost reason, or you should have a really good reason for not just welding all the way around, in my opinion. It's you know, you don't leave places for rust to develop. You know, water gets in there and freezes, and all kinds of things can happen when you leave, you know, small unwelded seams. This on the bottom here, because that is labeled on the bottom, that means it's on the near side. So if you're pointing to something that I can't see, for example, if this part was on the opposite side, then you would put the 3/16 on top. Sometimes your welds have to point to things that we can't see, or maybe it needs to be welded on both sides. You know, let's say I was pointing to this, let me zoom in here. Let's say I was pointing to this right here and it extended through the part and I needed you to weld this side and the other side. Then that weld symbol would show the weld 3/16. This is a fillet weld. And I would have it on the bottom and on the top. And that would tell the manufacturer to weld both sides of the part. If for some reason I can't get an arrow over here to point to this side, I can just point to this side and put the information on top of the line, and that would mean weld the far side. So anything on the bottom is near side, meaning in reference to where the arrow is pointing. Anything on the top is far side. Again, the circle means all around. And information in the tail is just kind of notes. You know, you might say three sides. In that case, you need to tell them which three sides with the arrows. In this case, I just say typical, which means anywhere you see these parts, anywhere you see that type of seam, go ahead and fill it in with 3/16 weld. Again, the assembly print, really the only dimensions that you would have are locations for things to land and overall dimensions for the assembly. Don't forget weights. It's always a good thing to have calculated weights on your drawings for individual parts and your assemblies. Don't worry about the weight of weld. That's usually not considered. I mean, unless you feel like you want to go that far. Not a whole lot here. I think this one's pretty self-explanatory. Remember, when you're dimensioning holes, dimension to the center points of the center lines of the holes. Don't just throw it here in the middle of the hole somewhere, and make sure all your holes have center lines. Really, this side view should probably have a center line, a horizontal center line for these holes as well. This is a good note. It shows that the holes in this I-beam only go through one flange of the I-beam. So make sure you say so. You know, don't just rely on the hidden lines here to say that. I mean, you can. It's not a bad drawing, but a better drawing is one that just puts it in the note that, you know, leaves no questions and less chance of an error. Again, you know, call out your material. It's a nice thing to do. If they're stock dimensions, they should probably say stock. Same thing. Nothing really exciting there. Notice all these part numbers. We've gone through 11. Here's number 12. These are all going to come together in another subassembly. This is a good example of pulling everything from one datum point. It would not be a great idea to dimension these holes from the left side of the part, these holes from the right side of the part, and then dimension the overall length of the part, which appears to be missing from this print. So don't do that. And then you're basically leaving the distance between the holes as sort of a, you know, open-ended thing. You know, whatever tolerance you gave them here, whatever tolerance you gave them here, whatever tolerance you gave them on the overall length, and then all that can add up to be the tolerance between the hole pattern. Now, maybe that's what you want. Just keep that in mind when you're dimensioning things. That what you drive the precision of certain parts by which things you measure. If the distance between the holes was really important because you needed it to mate with something that already had that distance established, that's probably what you should dimension. And the length of the part may not be the overall length may not be all that important. Don't do all three. Don't dimension from here to here, here to here, here to here, and an overall length. If you're going to do these three, just leave out the overall length, like I did. Only I should have dimensioned this as well. So this is another example of an assembly drawing. It's a sub-assembly. And this shows piece 8, 9, 10, 11, 12. You don't have to do your part numbers that way, but it's a pretty easy way to keep track of things. And so here I've also included a rear isometric view just because it, one, gave me a nice place to point to with welds, and two, I felt like it added some information, some clarity for these holes and how these parts came together. I wouldn't want this part to accidentally end up in there upside down or backwards or something. So got some overall dimensions and some location dimensions, showing where these things are positioned, but that's really all that should be on here. Don't tell me what this I-beam is again. You already told me on the print. Don't tell me how wide this tube is. You already told me on its print. These are basically new dimensions. Nothing should really be, restated here that was already said before. I personally like to do weld call outs on an isometric view, but it certainly isn't required. A lot of times you'll see them done on the standard drawing views, your two-dimensional views here. I don't know, to me it seems a little better because you get to see things. I don't know, isometric views just seem to be a better place to show it, but certainly up to you. Just keep in mind, you got your near side, your far side. And, of course, this is a fillet weld. You have symbols for bevel weld, symbols for butt weld. This symbol tells them what type of weld. If you guys are planning on doing any welding at, assembly, after this thing's put together, then you end up putting a little flag out here and it becomes a field weld. And that just means it's not welded during the manufacturing process. It's welded sort of at the site, at the final resting place of this thing. That probably not what you guys are going to do though, but if you did, then there's a field weld symbol to put on there. But lots of different options with weld symbols. You should probably just research them. I like to point to as many things with one weld symbol as I can though, because they can really clutter up a print. Take advantage of the typical, take advantage of all around, because if I had to point to each little location, a great example, I think, when we're looking at this foot being welded to this I-beam, certainly don't want to point to, I could say, well, I only need this side and this side welded, but it's just as, it's unless I'm really worried about the time it takes, why not just weld it all the way around? And so I can just point to that one place, and I've welded this entire plate all the way around the I-beam. Anywhere there's a weld seam, this thing's getting welded. If there's an area where you don't want weld because it's going to interfere with a mating part, weld seams basically add a radius everywhere they're put in, or a chamfer. Then just, you can say, you can point to it separately and say no weld here. And then it would say, typical unless noted or something. Just don't leave it up to guesswork. If you're going to do things, that are a little unusual to save yourself time, note it well and make a note. You can add notes all over if you want to. Just try to keep it from being cluttered. Nothing real special here. This is kind of what I was talking about with that other drawing. You got your overall length, you got your length here, no dimension here. Don't do that. If you're going to do that, then you need to lose the overall length. Nothing too exciting here. Just a piece of channel, but they still need a print. Not channel, L, angle iron, whatever. And another subassembly. So in this case, it took those last several parts we looked at. Here's all their part numbers. Okay, so just to point out too that, even though piece 18 is just a flat piece of plate, it came in, all we did was cut it to length. it still needs a manufacturing drawing. Now, here I didn't call it out as 3/8 by 3 flat bar. You know, it could be made out of plate. Heck, it could be made out of 3/8 by 6 or something if you wanted to cut it. But, you know, that's just a nice thing to say. Should probably say 3/8 stock if that's what you're going to buy, or that's what's on your bill of materials. If you're going to buy a 1/2 inch because you couldn't get 3/8 in this type of material, then it won't have stock dimensions on it. But anyway, point is, it still needs a print, even as simple as it is. And that also gives you a part number to reference in your assembly drawing. Same here. It's just a piece of angle. Now, little neat trick here. This thing was 174 inches and 3/4. That would not have fit on a drawing very well. If you ever do a drawing and you feel like you've lost the ability to show your part well because of how long it is, do a breakaway or a break line like this. There's different ways of doing it. This is a great example of you know, a fairly complex shape made out of something that was structural. You know, that's kind of a design thing, but instead of having to worry about welding these two pieces together and getting them straight, you just buy a piece of structural material and a few cuts, and you've got this, you know, kind of prefab section here. I don't think there's a lot going on here that's really interesting. Everything's dimensioned from the left side of the part. Obviously, this is going to be a cut that's going to be made, so it's dimensioned a little differently. But, you know, I could have lost that dimension and dimensioned this whole length of this edge instead. That might have been a little more consistent with pulling from the left. Didn't dimension the Y location or vertical location of all three of these holes. Just said 0.162 typical. Now, how do they know that they're all on the same line? Well, because they look like it. If you really wanted to say 3 places, you could. Don't put a dashed line across there because that's confusing. You know, just kind of as a rule of thumb, if things look 90 degrees, if they look parallel, if they look perpendicular, they are. And that's just a rule of thumb with drawings. You know, anytime you're going to have a 99.5 degree angle on a drawing, you're going to dimension, or an 89.5 degree angle on a drawing, you're going to dimension it. So if you leave me something that looks 90, I'm going to assume it's 90. You don't need to call out all those things. And like I said, in this case, if they look like they're in line, then I'm going to assume that they are if you say typical. Again, tangent lines, which is what we're seeing here in these radii, they are optional. It's really going to be, it's up to the person, your boss. I guess we can talk to Dave. Dr. Dave has mentioned tangent lines before, and I don't remember if he said he liked them or didn't like them, so we'll clear that up maybe. But that is an option you can turn on and off in your software. I'm used to seeing them myself. Another subassembly. Again, if you're going to do weird things, note them. It's not wrong. Just make sure that you call them out clearly in a note. So position and drill to fit railing 811 through. So basically, we had a subassembly that was a railing that was going to bolt to these two parts. Well, that tolerance maybe was pretty big. And I don't want to have this thing, you know, real sloppy. I don't want to put really big holes in it. So what I want to do is just say, make it fit the mating part. And while that's a little unusual, it's you know, not completely uncommon, especially on a large weldment. So sometimes, even though all the manufacturing drawings are done, maybe you do an overview sort of installation drawing. You know, this kind of highlighted the wider system is what this drawing shows. These are platforms that were made to surround a generator. So, you know, what we have here is the width between the two platforms when they're installed, so that somebody can say, oh yeah, that won't, you know, the generator will fit in there. There was some concern, you know, about handrail height for OSHA requirements, you know, so they can see that that was met. You know, and it just kind of brings the wider system into view, and maybe helpful for somebody installing it, making sure that there's a big enough concrete pad for this thing. You know, more of an installation thing than a manufacturing thing. But I think that pretty much wraps it up.